Number 1, you got a polynomial. Now you have 5 terms, 5 pieces, and it is organized in standard form. So all these pieces, none of them are like terms, and you identify pieces by their degree, and that is the exponent that is with them. So 4 is the biggest exponent. It's a quartic. It goes first in descending order. So degree 3, degree 2, this is degree 1, and anything with degree 0, since anything to the 0 is 1, that's really like 10 times 1, which is just 10. That is a constant. So a number with no variable is a constant. 1 is linear, 2 is quadratic, 3 is cubic, 4 is quartic, 5 is quintic. So this is a 1, 2, 3, 4, 5. It is scientifically a quartic polynomial with 5 terms. And only the first 3 terms have names. So if it's just a 1 term, it's a monomial, 2 terms binomial, 3 terms trinomial. So the coefficient of the 3rd degree term, that is how many of them you've got, and you have a -7 cubes. And what is the coefficient of the 1st degree term? That's how many you've got. You've got 2. A ball is dropped from 5,000 meters above the ground. The distance it has fallen after t seconds is expressed as 0.49 times every second squared. Which expression represents the height of the ball after so many seconds? So you're going to start at 5 grand, and then you are going to take away, this formula gives us distance traveled. So if it travels for 2 seconds, you can plug, this is time, this is time, and this is distance. So if you want to know how long it's traveled for 2 seconds, you plug 2 in for t. So it's 4.9 times 2 squared. So it is 4.9 times 4. And that is going to be 19.6 seconds. But if I want to know its position, I'm going to do 5 grand minus the 19.6, and that will tell me its height. So that's why we're going to go with C. Number 3. What are the solutions to this quadratic equation? Okay, quadratic equation. You know it's a quadratic because the degree is 2. And if you, sometimes you can factor them, but if all else fails, you can do the quadratic formula on any quadratic to get the solutions. Solutions are also called zeros, and they're also called roots. So we got to solve for x. And if you can factor, that's the easiest. So always try and factor it. So this one, we got a 0 here. That's nice. I can factor x out. So if I go x times x minus 8 equals 0, okay, now it's going to be not too bad, because you have a multiplication problem and your answer is 0. The only way you can get an outcome of 0 is if you are timesing by 0. So either this factor is 0 or this factor is 0. And those are the 2 numbers that will make both of these 0, which would make your answer 0. So 0 and 8. Number 4. Okay, this one, just looking at the answers, they're ugly. And if they're ugly, that means you probably cannot factor them, which means we're going to do the quadratic formula. So, quadratic formula, x equals negative b, plus or minus square root of b squared minus 4ac all over 2a. So, got to put it in order. It is already in standard form. A is how many squares you got, B is how many linear pieces you got, and C is how many constants you got. So A is going to be 3, that's how many squares I've got. B is a -2, and C is 1. So if I start plugging them in, it is x equals a negative b, and b is negative, plus or minus the square root of, put this in parentheses, b squared minus 4ac. If that's not in parentheses, that's where a lot of common mistakes are, because if you square b, you have to square the negative. Because there's a big difference in your calculator if you type in negative 2 times 2, or negative 2 squared, versus a negative 2 squared. The parentheses mean you got to include the negative. If you don't put parentheses, you are not including the negative. And it's just going to be a negative 2 times 2, which is a negative 4. But you got to include the negative, because a negative 2 times itself a negative 2, we need a positive 4. So don't make that mistake. Well, hold on. I got a little carried away. Let's put in a and c. 4 times a is 3, times c is 1, all divided by 2 times a, 2 times 3. Okay, so if I simplify that, I have a positive 2 plus or minus the square root of 4, that's a 1. 4 minus 12, all divided by 6. Okay, if I keep going, I got 2 plus or minus the square root of a negative 8, all divided by 6. Now, big red flag. Anytime you got the square root of a negative, square root of a negative is the definition of an imaginary. That is the imaginary number. So, I'm going to take that negative out. It becomes 2 plus or minus imaginary square root of 8, all divided by 6. And square root of 8, you can break that down. 8 is 2 times 2 times 2, so I'm going to take a 2 out and leave a 2 in, and 2 plus or minus 2 imaginaries, 2 divided by 6. Okay, now you're dividing both of these terms by 6. You're dividing the constant over here by 6, and you're dividing this imaginary by 6. And 2 and 6 and 2 and 6, change that to a 1, change that to a 1, change that to a 3. So, we're going to go with C. Number 5. Okay. So, check this out. This is a quadratic. So you can find ABC. To find ABC, first of all, you got to do the square. You got to do x minus 9 times x minus 9. X minus 9, x minus 9. Distribute that out, then times that by 4, and then move the 5 over. And that will give you, the quadratic formula will always work. So if you don't know what to do quadratic formula. Now, I'm going to ditch this 4. It's 4 times. So I'm going to divide 4, divide 4. So we got 5 divided 4 equals x minus 9 square. Now I'm going to ditch the square, and the inverse of a square is square root. So I square root this, but when I square root this, I got to do both roots, the plus and the minus. So now I got a fraction under the radical. You cannot have a fraction under the radical. So that is the same thing as that. You can take the radical to the numerator and the denominator. And then the denominator, you cannot have a radical in the denominator, but we're lucky because that is not a square root of 4, that's a whole number. So you got this, you got plus or minus square root of 5 on top, on bottom you got 2. And that square and radical undo, so you got x minus 9. Now you just got to undo the minus 9, so plus 9 on this side, plus 9 on this side. So your answer is 9 plus or minus square root of 5 divided 2. Looks like they're all C. C, 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 C. Okay, roots, that's the same thing as a solution. And it is already in standard form and it doesn't look too funky. So first try and factor it. Do there exist numbers that times and give you a minus 20 and at the same time add and give you 19? And the answer is yes. We can use 20 and 1. They must times to give a negative, so one of them is negative. And they must add to give a positive 19, so I know I'm going to go with 20 to minus 1. So here we go. It's now going to be y equals x plus 20 and x minus 1. And the roots are when y equals 0. So let's put 0 here. If I go 0 equals x plus 20 and x minus 1, that means x is equal to a minus 20 or a plus 1. So a minus 20 and a plus 1. And what that means is your graph at a minus 20 on the x, so clear over here, and a plus 1, you have two roots. And I know since a is a positive 1, my parabola is going to look something, it's going to open up. So there are your two roots. If you're looking at a graph, your roots are where it crosses the x axis when the y number line is 0. So that's why they're called zeros. 7. Select the graph of this system. Okay, so a system is two equations, so you got a circle. Your center is at h and k, and it is x minus the h square plus y minus the k square equals the r square. So there's a couple circles to choose from. The h is hanging out with the x, and there's nothing with the x or the y. So the center is at 0, 0, which all of them are. The radius is tricky. It is not 4. The radius is 2, because 4 is really 2 squared. So that means you can kill C and D. Okay, so now this guy, y equals 2. Y equals 2 is a simple graph. There's only one variable, so it's going to be horizontal. It's going through the y-axis at 2. So we're going to go for A. The y number line at 2, right there. Where these 2 points, these two graphs intersect, it looks like it's a tangent line. That is the only dot they have in common, so that is a solution to the system. B, this line right here, is the graph of x equals 2 because it only goes through the x-axis at 2. 8. Completing the square. Here we go. That means they gave you a bogus c. So you want to complete the square at x squared plus 2x plus what is going to make this guy a perfect square. So to find what's going to make it a perfect square, it is always b divided by 2 squared. So you add to get the middle. What's going to add itself to give 2? And that is 1. 1 plus 1 is 2, but it's got a times to give this. So 1 times 1 is also 1. Okay, now if you factor this, this will factor into a perfect square. X plus 1 times x plus 1, so that is going to be x plus 1 squared. But if you plus a 1 on this side, you got a plus a 1 on this side. So you got to drop a 6 there and an x plus 1 there. And that is this original transformed into a perfect square. So with a little manipulation, you turned it into a perfect square. A square has sides that measure x plus 5 units long. X plus 5, x plus 5. Area, okay, that's not bad. Area just equals height times width, base times height. So you just do x plus 5 times x plus 5. You distribute, boom, 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 add your like terms. And we're going to go with D. Because x times x is x squared, x times 5 is 5x, 5 times x is 5x, 5 times 5 is 25. And 5x and 5x is 10x. 10. Okay, consider this function. Which of the following is a maximum or a minimum? Okay, so check it out. We can eliminate two of them real quick. So this type of a parabola has a maximum, because that's the highest point. This type of a parabola has a minimum, because that's the lowest point. And what flips them upside down is when A is a positive, it looks like this guy. But when A is negative, it flips it upside down. So your A is actually 3. So it's going to look like this guy's positive. So I can kill, we're going to have a minimum. I can kill B, and I can kill D. So now, are we going to go with A, minimum of 2? At X is 1, or are we going to go with a minimum of a negative 4? X is 3. So here we go. To find the vertex, we want to know where the vertex is. That's that minimum. Okay, the vertex is, so we've got to recall this, there is a line of symmetry. Okay, we got a graph. Okay, this dot right here, the C, that's your y-intercept. So up here at 5, we're going to have a y-intercept. Now let's find your line of symmetry. Your line of symmetry is a negative b over 2a. So my line of symmetry is negative b, negative 6 divided by 2 times 3. And that is at a negative 1. So over here at negative 1, that is your line of symmetry. So let's see if that gets us anything. Uh-oh. So I'm looking at the minimums. Neither one of them say x is, this says x is 1 and this says x is 3. So, no. This is right, this is wrong. So a negative 6, that's a positive. So a positive 6 divided by 6 is at a positive 1. I don't know why I got negative 1. Alright, so they are right. I am wrong. So x is at 1. So that means we're going to go A. But now to find where your vertex is, all you got to do is plug this dot in. Let's plug, because we know the vertex is x is 1, so let's plug 1 in. 1 squared, because this is y, is 1. 1 times 3 is 3. A minus 6 times 1 is a minus 6, and a plus 5. So I've got 3 and 5 is 8. Minus 6 is 2. So x is 1 and y is 2. So that means, so check it out, that worked. Y is 2. Up here at 2, you got a dot. Then this dot flips over here for free, and boom, there is your parabola. Okay. Ooh. This guy, let's check it out. A factorable, it says it's factorable. So they want you to factor it, not use the quadratic formula. That's nice. Here we go. Move number 1. Okay, let's shrink it down a little bit. 6 and 21 and 12. Let's factor a 3 out of each of those. So we can, that's just function notation for y. Y equals 3 times 2x squared plus 7x minus 4. Okay. Now to factor this, most of you honors kids are pretty good at just doing it in your head. If you can't do it in your head, if your A is not a 1, if it does not start with a 1, this is not a perfect square. That's not a perfect square either, because it's a negative 4. So it's not a special case. We're going to change this trinomial into 4 pieces. So really, here's what I got. 2x squared plus blank minus 4. You're going to take the first coefficient and this last constant, times them together, and that is a negative 8. The middle times the middle will also be a negative 8. So what times and gives you -8 but adds and gives 7? It's going to be 8 and 1, and the 1 is negative. Because 8 times -1 is -8, but they add to give you 7. So I'm going to go 8x minus 1x. Okay, now that you got 4 pieces, let's group them. So, I'm going to group these together, and I'm going to factor out a 2x. So it's going to be this 3 parentheses 2x times x plus 4. And out of these guys, I'm going to factor out just a -1. So it's going to be minus 1 x plus 4. Okay, now it's going to be 3 parentheses x plus 4 parentheses 2. It's going to be this guy, 2x, and this guy, minus 1. And I guess I don't really need a parenthesis here. So now, if that is equal to y, but if I want the 0, let's make y be 0. What is going to make this all times to give 0? So you kind of just ignore this 3, because it's going to be 3 times this. I want this to be a 0, so that is x equals a minus 4. Or I want this to be a 0. So how are you going to make 2x minus 1 a 0? 2x minus 1, just make it equal to 0. 2x minus 1 equals 0. This other one was pretty easy to do in your head. Plus 1, 2x equals 1, divide by 2, divide by 2. So it is a half. So your two zeros are a -4 and 1/2. So which of those two is the greatest? Which one's bigger? 1/2 is much bigger than a -4, so we're going to go B. Okay, the volume of a sphere, 4/3 pi r cubed. R is the radius, and rewrite it so that you solve for r. So let's get r by itself. Ditch the cube, ditch the pi, ditch the 4/3. So the pi and the 4/3 are timesing to the r. So let's undo the times. Let's divide this by 4/3 pi, and let's divide this by 4/3 pi. So you are going to have v divided by 4/3 pi. And remember, v divided by 4/3 is the same thing as v times 3/4 times by the reciprocal. You can make v a fraction, put it over 1, and dividing by a fraction is the same as timesing by the reciprocal. So on top we should have v and 3, and on bottom we need to have the pi and the 4. So we gotta have 4 pi. Then over here you got r cubed. So let's ditch the cube. And how you undo a cube is you do cube root. So cube root of this. And let's see, does that match A, B, C, or D? It is going to match A. Because that is the same as V on top. You could put V over 1.